Okay, hello everyone, in a new video. In this one we are going to solve an exercise related to optics and the chapters of lenses and formation of images. This exercise was the previous one in the Brevet exams in 2013, second session, first exercise. The title of this exercise is Focal Length of a Converging Lens. The aim of this exercise is to determine the focal length of a converging lens. On the diagram below, they mentioned the diagram. So now I can use it. AB represents a luminous object, L a converging lens, and E a screen on which the image A prime B prime of AB is given by L. Then here the image A prime B prime of AB is being collected on the screen E. Part 1, showing evidence of the nature of L. So number 1. In number 1 they are telling me, is the image A prime B prime of AB real or virtual? Justify. Then in other words they are asking me about the nature of the image. And here, because the image is being collected on the screen E, then the image is real, because we know that only a real image can be collected on the screen. Then let's say, since it's collected on the screen, then in this case, then the image A prime B prime is real. And now in number 2 they are telling me deduce that L is a converging lens. And the word deduce means here that we need to use the part just previously before. So in number 1 we have justify whether the image is real. So, and this means that L is a converging lens, because we know that only a converging lens can form a real image which can be collected on the screen. Then let's say, since a converging lens can form a real image, which can be collected on the screen, then L is a converging lens. So now in part 2 they are telling me determination of the focal length of L. Then number 1 they are telling me redraw on the graph paper and by same scale the above diagram. Notice that here in the direction of propagation of light is taken to be from left to right. And whenever we need to redraw, we always start by drawing the optical axis at the center or the middle, having the same direction of propagation of light, which is from left to right. Then this is x prime, this is x. Then we place the lens L perpendicular to the optical axis at the center, using the correct symbol of a converging lens. And the intersection between the optical axis and the lens L is the optical center O. Now the point A is located in front of the lens on the optical axis by 1, 2, 3 divisions. And the point B is located 1 division above A. A hat is found on B. And now let's trace the object AB. Moreover, the screen E is located behind the lens by 1, 2, 3, 4, 5, 6 divisions perpendicular to the optical axis. Then 1, 2, 3, 4, 5, 6. This is the screen E. Finally, the scale along the x-axis is given by 2 centimeters, and along the y-axis is given by 1 centimeter. So this is it for the redrawing. Now in number 2, they are telling me place on the drawn diagram the point image A prime of A given by L, justify. Then because they told me justify, so we need to trace the image A prime of A and justify it as well. Okay, so notice that here, because A is on the optical axis, then its image A prime will be on the optical axis. Moreover, in number 1, or in the given, they told me that the image is being collected on the screen. So we know that A prime will be on the optical axis and it will be on the screen. Therefore, it will be the intersection between the optical axis and the screen. So this will be A prime. This is the tracing of the image A prime of A. Now let's do the justification. Then let's say since the object is on the optical axis, then its image will be on the optical axis. And it is collected on the screen. For this reason, then the image A prime of A is the intersection between the optical axis and the screen. Now in 3 part A, they are telling me by tracing one particular ray issued from B, construct the image B prime of B. And here the word construct means that we need to trace and justify at the same time. So by tracing one particular ray, we need to construct the image B prime of B. And because they told me construct, so we need to trace this ray and justify it as well. And we need to trace the image B prime and justify it as well by using one particular ray. Okay, so here they didn't specify which ray that we should use, so we are free to use any of the particular rays that we know. So we can consider one issued from B parallel to the optical axis or passing through the optical center. Here we don't know the position of the object focus. Okay, so we will consider the one issued from B and passing through the optical center. We know that it will emerge without deviation, and we don't forget arrows on light rays that indicate the direction of propagation of light. So we have done the tracing of this ray. Now let's do the justification. Okay, an incident ray issued from B passing through the optical center emerges without deviation. Then this is the justification of the tracing of the ray. Now we need to trace the image B prime and justify it. So notice that because B, the object B is belonging to this incident ray, so the image B prime will belong to this emergent ray, and we already know that the image is being collected on the screen. Then the image B prime of B will be the intersection between the emergent ray and the screen, so this is B prime. Moreover, a hat is found on B directed away from the optical axis like this, then we must place a hat on B prime directed away from the optical axis like this. So this is the hat. And this is the tracing of the image. Now let's do the justification. Then the image B prime of B is the intersection of the emergent ray with the screen. Then done for 3 part A. Now in part B they are telling me trace the image A prime B prime of AB, deduce its dice. So now we know the position of the point image A prime, and we know the position of the image B prime of B. Then we can trace A prime B prime like this. And now we can calculate the size of the image. So size of the image A prime B prime so A prime B prime consists of 2 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis. This will give us 2. Since the scale is in centimeters, then the size of the image A prime B prime will be in centimeter. Always, all quantities in physics must have unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. This is it for 3 part B. Now in number 4 they are telling me trace the path of a luminous ray issued from B and parallel to the optical axis. Here, because they told me only trace, so no need to justify, we need to trace the path of a luminous ray issued from B. This is issued from B and parallel to the optical axis. So we know that always incident parallel ray is related to the image focus. However, in this case we don't know the position of the image focus. We know the position of the image B prime of B, and we know that all incident rays issued from B emerges going to B prime. And we don't forget arrows on light rays that indicate the direction of propagation of light. Then done for part 4. Now in 5 part A, they are telling me indicate the position of the image focus f prime of L, explain. So we know that always the incident parallel ray is related to the image focus, therefore the intersection of the emergent ray with the optical axis will be the image focus, denoted by f prime, and the justification is given by that then the image focus f prime is the intersection of the emergent ray with the optical axis. Now in part B they are telling me deduce the focal length f of L, and the word deduce means that we need to use the part just previously before. In 5 part A we have determined the position of the image focus, and we already know the position of the optical center, therefore we can deduce the focal length f by referring to its definition, which is given by the focal length is the distance from the optical center to the image focus. So f is equal to the distance from the optical center, which is the point O, to the image focus, which is the point f prime. And we don't forget the bar because this distance may be positive or negative. Then f is equal to f prime bar, which is the distance from the optical center to the image focus. Notice that this distance is in the same direction of the positive x-axis, so it's positive. And now we count the number of divisions between O and f prime. We have 1, 2. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. This will give us 4. Since the scale is in centimeters, then the value of f will be in centimeters. Then f is equal to 4 centimeters. Then the focal length in this case is positive, which verifies that the used lens is a converging lens, because we know that for a converging lens, the focal length is always positive. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.